So, hello, I'm Radha Gupta, working as a full stack developer at Thodos and total 1.5 year of experience in IT industry. And till now, I have worked on very technology like React.js, JavaScript, Java, and many more. So, if I talk about my teaching experience, so like in my college, I was leading coding blogs department of my college. I was one of the member of it, and sometimes I used to take classes to my juniors to clear their data structure doubts or algorithms or anything related to the DSA algo. I was taking classes, so that was it. And I'm very passionate about teaching, and I'm looking for a teaching profession in a tech companies. So yeah, let's start our today's session. So let me explain that what is going for today. So like our today agenda is uh, yeah. So let me tell you that what is the today's agenda. So as you can see on the screen that what all things we are going to explain today. So today we are going to explain that what is recursion. That is a very informative and a very important topic from DSA. So that is very good thing. The next we will discuss about that why we need. So what I wanted to say is like before going and to learn anything, we first understand that why we are learning this thing, right? So for that only, I will tell you that why we need recursion. Then we will see that what are the application. I mean, where all we can use the recursion and all, right? So that is other thing. I will teach you that, we'll go in deep and we'll understand that how recursion works and internally how recursion works, that we will understand what are the applications like, what all problems, data structure problems we can solve by using recursion and how to implement this. I will take an example and will show you that how it's working and, so what are the uses and all. So that are the agenda for the today. So without any delay, let's jump into our session. So yeah, let's first start that what is recursion. So basically, as you can see on the screen, that recursion is a method where the solution to a problem depends on solutions to a smaller instances of the same problem. What I basically mean to say is like, let me tell you in a very simple, a word. So basically the process, what is recursion? So recursion is basically, a process of solving a problem by reducing it into a smaller version. You will understand that what I wanted to say as soon as we deep dive into the session. But for now, you just understand that let's suppose you have a very big problem and you wanted to solve it. So to solve that, what we basically do is like we break the problems into a smaller version. And how we can achieve is like the function will call itself to get the solution of a smaller version. So here you can see that how it works is like it works on the principle of divide and conquer technique. So let me tell you that what is divide and conquer technique. So it's basically nothing. As I told you that to solve a recursion problem, what we basically do is like we divide the problem into sub problems, get the solution of sub problems, and combine the solution of sub problems to get the solution of bigger problems. Let's understand that what I mean to say. So here on the board, you can see here you can see that something is happening. There is one tree. So let's jump to the whiteboard and see that what I wanted to show, right? So here, what you can see is like we wanted to calculate the factorial of 7, right? So to calculate the factorial of 7, uh, let me tell you one thing that if I give you the so basically just tell me that what is factorial first. So factorial of 7 is equals to 7 into 6 into 5 into 4 into 3 into 2 into 1. So the result of this will be the factorial of 7. So, if I will give you the factorial of 6, then what will be your job left for me is only to multiply the 6 into factorial of 7 into factorial of 6, right? So, to get the factorial of 6, what you need is like if I will give you the factorial of 6, factorial of 5, then what simply you will do is like 6 into factorial of 5 and your job will be done, right? So in the same way, what you will do is like 7 into 6 into factorial of 5 into factorial of 4, right? So in the same way, uh, 7 into 6 into 5 into 4 into factorial of 3, right? And at the end, you will be, this will be the thing like 7 into 6 into 5 into 4 into 3 into 2 into factorial of 1, right? And factorial of 1, we know what it is. Factorial of 1 is 1, right? So we know the factorial of 1, then simply this thing will return to 2 and this thing will return to 3, right? So we will discuss this in a, deep dive in the coming session. So what basically we are doing is like, as we told you that we are dividing a problem, getting the solution of that smaller version and combining it. So let's understand that how it is fitting in the solution, right? So here you can see is like we wanted to calculate the factorial of 7, right? Fac- Factor, Factorial of 7. So to getting factorial of 7, what we are is getting doing is like we are dividing it. So we are dividing into smaller version. I mean, if someone can give me the factorial of 6, no, I can easily calculate and return the factorial of 7. Then what factorial of 6 is saying, if someone can give me the factorial of 5, no, then I can simply return the factorial of 6. In the same way, if someone tell me that the factorial of 4, no, I can simply return the factorial of 5. So we are dividing it, right? What we are doing is like we are dividing it to a smaller version, up to a smaller version. So we are dividing it by the up to the factorial of 1. And here we know the result. So our job is done and we can return it, right? So I hope this is the thing is clear to you is like first we will calculate the factorial of 1, then we calculate the factorial of 2, calculate the factorial of 3, then 4, then 5, then 6, and finally we are combining it, right, to calculate the factorial of 7. So basically the same job we are doing here, dividing the problems into sub problems, get the solution to it, and recombine the solution to get the factorial of 7. I mean, to get the solution of bigger number, right? So that is the thing. I mean, what it is and how how it works, that I will explain. But what is recursion? That is the thing. So now let's jump and move forward. So yeah, basically, I will tell you that why we need recursion. We have a lot of data structure, but apart from that, why we need it. So like every data structure has its own job, as you might be knowing about that. But yeah, basically what recursion does is like, there are some problems or there are some data structures problems that you can, easily solve by using recursion. You might have heard about the graph problems or binary tree problems, or even binary search or merge sort, weak sort. So these all concepts use the concept of recursion. So there are a lot of questions or a lot of things in which you need a recursion concept to solve it very easily. Even if you go to write the code iteratively, then you will be ended up with writing a lot of code, and it will take a lot of time, and also it's not very easy to understand, and obviously the time complexity will also increases. So that are the some use case of recursion. So yeah, now it's time to deep dive into it and understand that how it is and what are the all things. So basically, let me tell you one more thing, that recursion contains the two concept, right? So here you can see I have written a snippet of code, right? So yeah, sorry, snippet of code here I have written. So basically you can see that there is a function with some argument. There is a base condition, and there is a base condition, and here is a recursive function. So let me tell you that what is recursive function first. So basically, so before recursive function is, it is what, like it's a function that call itself until a base condition is true and execution stops, right? So let's understand that what is the base condition and what is the recursive structure. So recursion contains two things. One, it is a base condition, and the other, it is a recursive function. So let's understand that what these two things are. So let me explain you that. Let's jump to the here and tell me that what is the base condition first. So base condition is something for which you already know the solution. Let's take this example again, and you can see that to calculate the factorial of 7, we already know the factorial of 1. Let's take a bigger example. If you want to calculate the factorial of 100, so you might be not knowing the factorial of 99 or factorial of 50, right? For that, you need to calculate Google or something. But you know the factorial of 1, right? So, as we know, the factorial of 1 is 1, right? So, so the thing is that we already know the factorial of 1 is 1. So, the base condition is something for which we already know the solution, and there we stop our execution. So, for this example, what is the thing is like we already know the factorial of 1, that is, yeah, factorial of 1, that is 1. So here we will stop the calculation and we will not go further beyond that to uh, still break it, right? So here we will stop our breaking, and from here so yeah, that is the base condition. Now let's understand what is the recursive call. So recursive call is like, for that we need to take pseudocode, and let's take an example to understand it better. So yeah, let me take an example of factorial, right? So here you can see if you want to calculate the factorial of 4, right? So factorial of 4 is like, as I already explained you, that the factorial of 4 will must be dependent on the factorial of 3, then factorial of 3 is dependent on factorial of 2, and then factorial of 2 is dependent on factorial of 1. So let me take a pseudocode, and then I will jump again to this, tree flowchart. So let's take a pseudocode of this problem. So what is it like? What I have written here is like, you can see there is a function called fact, right? We are getting an argument, that is a number, and we are checking here is like, if number is equals to 0, then return 1. So factorial of 0 is 1, that we already know, right? So that will be the base condition. And what if if the number is not 0, right? So if the number is not 0, then what we will do is like, uh, then obviously the code will not enter in this if condition, and we will go here, and what we will do is like, let's suppose in this case it was 4. So 4 into factorial of n minus 1, that is factorial of 3. So what it will do is like, here we are calling the function, right? So here we are calling the function, so the execution will again go here, and this time here the n is what, the n is 3. So again this if condition is not true, and it will again go here. Now the thing is 3 into, so already we have 4, now 4 into 3 into factorial of 2, now n minus 1 is 2. Again the execution will go here. Now again here it is 2. Again this if condition will not be valid, then again it will go here, write 4 into 3 into 2, then 2 minus 1 is 1, that is 1. Then again it will go here, and again it will come here, then 4 into 3 into 2 into 1, then again it will go here, then now the n is 0, so it will return as 1, right? So here it will return 1. So as soon as we will achieve the best get the base condition, it will return and print the whatever will be the output, right? So that's the scenario. Now let's move back to this phase, and here you can see what is like, at the first what will happen. Sorry. So yeah, at first the factorial of 4 will come. Then what it needs? It needs a factorial of 3, then factorial of 2, then factorial of 1, then factorial of 0. We already know the factorial of 0, so it will return 1 here. That is the base condition. It will return 1 to the function that is calling the factorial of 0. So it will return 1 to the factorial of 1. What we are doing here is like 1 into factorial of 0. So 1 into factorial of 0, that is 1 into 1. So it will return 1 to the factorial of 2. What was the for this thing, what was that? 2 into factorial of 1. So 2 into factorial of 1 is 1. So that is 2. So it will go here for 3. 3 into factorial of 2. So 3 into factorial of 2 is 2. So it will go here. And for the factorial of 4, that was 4 into factorial of 3. So factorial of 3 is returning 6. So 4 into 6 is 24. So in this way, we can calculate the factorial of 4. So now let's see that how the recursion is working internally. But before that, let's go and code it, right? To see that how it is working. So let me go and write the code for the calculation of factorial, right? So let me first remove this thing. Let's take a number. Let's take a variable uh, and store a number 5 into it, for which we wanted to calculate the factorial, right? And let's make a function. Let's suppose name of the function would be calculate factorial, and pass this number to this function, right? Now let's go and make this function working using space, right? So the return type of this function will be int only, and let's take one argument, right? So our job is what? Our job is to calculate the factorial. So we can simply write return number into what? Number into then this function, this calculate factorial function will call itself with what? With n minus 1. So how we can do that? Let's see. So we can do that in this way. Calculate factorial number minus 1, right? But we need a base condition, right? Base condition is what? Base condition is something for which we already know the solutions. So we can write that if number equals to 0, right? Then what we have to do? So we have to simply return 1 here. Yeah. So let's declare one result variable and store the result of this to print out. Then we can simply print out factorial of 5 is factorial of 5 is space and then result, right? Now let's run it. So you can see the factorial of 5 is what? 120, right? TORLE factorial of 5 is 120, right? So yeah, let's understand it how it is working. So as you can see, what we are doing is like we have one main method, then we are declaring a variable for which you wanted to calculate the factorial, that is fine 5. Now we are just calling this calculate factorial function and passing this number, right? So as soon as you pass this number, call this function, the execution will go there. And what we are doing is like, first we have written a base case here. So what is the base case is like, if number equals to 0, that is the base condition for which we already know the solution. What we have to do is like simply return 1. If you don't know, then what we will do is like return number, what the number is here, number into calculate factorial, and for what? For the next execution, it will be number minus 1. So let's see, like for this one, at very first, here it will come the 5, right? So at let's do a dry run. So here it will come 5, that is not equals to 0. So it will not move into this. Now return, so the execution go here. And what will happen is like 5 into calculate factorial of 5 minus 1, that is 4. The same what we have seen on the whiteboard, right? There what we were also doing is like calculate factorial of 7, it means 7 into calculate factorial of 6. So here that is the same line written here. Number, that is 5 into calculate factorial of 4. Now the execution go here, then again it will not be go inside this if condition. It will again come here. What is it is for this time, what it will be here is like 5 into 4 into calculate factorial of 3, right? Then again it will go here, this will not enter in this, then 5 into 4 into 3 into factorial of 2, and the same way it will go. And as the number becomes 0, it will return 1. So 5 into 4 into 3 into 2 into 1, that is 120. So that is the output that we are returning here. Now let's understand that how it's run internally. So for the execution of the recursive functions, compiler use called stack, right, which is based on the stack data structure. So if you are already not familiar about the stack, that what it is, so basically let's take a very real world example what it is a stack. So basically it's a data structure that works on the principle of last in, first out. What basically I mean is like, let's suppose you have 10 books and you are keeping books on, top of one another, right? So the book that you will keep at the end, that is the book that you can put first, right? If you have to, take the last, take that book that you have kept very first, for that you need to first remove the 9 book, and then only you can take that the 10th book, right? So basically it's like stack means keeping the things on top of the each other, and it works on the principle of last in, first out. The thing that you will keep at, that you will put at the last, that you can take it first. So it basically works on the principle of stack data structure. Now, how the execution happens, like you have seen in the code that what we were doing there is like calculate factorial of 5 means 5 into calculate factorial of 4. So here you can see is like order of execution of function call is like factorial of n means factorial of 5, then factorial of 4, then factorial of 3, then 2, and so on, then up to 0. And how the value is returning, that is the reverse way, because we know the factorial of 0, right? So the factorial of 0 will return first, then factorial of 1, and in the same way, at last we will return the factorial of n. So let's jump to the whiteboard and understand that how it is working, right? So yeah, so let me take an example that I want to calculate the factorial of 5. So how the thing is working? Let me make a stack, bigger stack. So what is happening is like, in the code, just try to remember from the code, what we were doing is like 5. First, we want to calculate the factorial of 5. And what it is like 5 into factorial of 4, right? So, to calculate the factorial of 4, what it is? 4 into factorial of 3. Then to calculate the factorial of 3, what is the thing is like 3 into factorial of 2. So in the same way, it will go. So how the stack will look like is just make a smaller stack and just keep it simple. Factorial of 5. First, the call will go for factorial of 5. Then call will go for factorial of 4. Then call will go for factorial of 3. Then call will go for factorial of 2. Then call will go for factorial of 1. Then factorial of 0, right? And so this is the base condition, right? This is the base condition for which we already know the solution, right? So the factorial of 1 is what? Factorial of 1 is 1. So it will return 1 to that function from which it is calling. So let's understand, or let's think, you can pause the video and can think that which function is calling the factorial of 0. So let me tell you that this factorial of 1, what is for is like factorial of 1 is equal to 1 into factorial of 0, right? Means this factorial of 1 is calling the factorial of 0, right? So it will return what we have written in the code is like it will return, right? So it will return 1 to the factorial of 1, correct? Now so yeah, as soon as we return means so as soon as they in the stack, as the function call will enter, a memory is allocated to it, right? So and once it will get the value, once it will get the return, it will be removed from the stack. So this will be removed from the stack. Now in the stack we have 5 elements. What now we have solved this function, right? What was our requirement is like 1 into factorial of 0. We know the factorial of 0, so that is solved. Now the value for this level will be 1. Now let's see that which call is calling the factorial of 1. So here you can see for the factorial of 2, what was the thing? 2 into factorial of 1. So this level is calling the factorial of 1. So it will return what, and what is the factorial of 1? That is 1. So it will return 1 to here, and this will be removed from the stack, right? Now uh, uh, for this level, what is the value? That is 2. Now as soon as we come here, what it is? 3 into factorial of 2, and we know the factorial of 2. So what it is? 2 into 1, that is 2. So it will return the 2 to it. And what it is? 3 into 2, that is, so it will return the 2 to it, and the value for this will be 6, correct? Now this will be removed from the stack. Now the execution comes here. 4 into factorial of 3. 4, and we know the factorial of 3 is 6. So the value for it will be what? 4 into 6, that will be 24. And this will be removed from the stack. Now the execution comes here, and what it is? 5 into factorial of 4. And we know the factorial of 4, that is 24. So 5 into 24, that is equals to 120. It will be removed, and this will also be removed. So what we have seen is like this is the stack, and how the recursive call is happening, how we are achieving the base condition, how we are dividing the problem into some small chunks, getting the solution, and then recombining it. So I hope that at this point of view you will be able to recollect and combine all the concept what we have seen till now. So this is the internal implementation of recursion, that how it works. And here in the code you can see that this is the base condition. Till here this is the base condition, and this is the recursive call. So that is the two main part of the recursion. That is the base condition and the recursive call. So everything depends on this thing only. So basically, yeah. So that's the thing. And now I will give you one more example to understand it better. So yeah, let's see that this is, you might be heard about the traversal of the binary tree or binary search tree. So this is the code for that. Let's don't worry about that, how the code is working and all. That is another concept. So, but to understand that how recursion helps us, you can see that the job of both code is same, like both the code is doing what the printing, post auto traversal we are doing for the binary tree, and see that how the code is precise and easy to understand, right? So so you can see that how the code is precise and easy to understand, and this is the same code, the functionality is same, but it is the iterative approach. And you can see that how it's difficult to understand, and also the complexity will also be increased. So just to understand that how recursion makes your job easy, once you understand and become pro in that, no, you will be kind of that you can solve the problem in a very simple and easiest way. So just to see that what is the how the differences is there, I have kept in one example. Let's not understand that what this is doing, but just see that how it is different. This is a iterative solution only to do a post auto traversal, and this is a recursive solution. Both the functionality is same, but see that how differences is this. So yeah, we have some application, like as I already told you that what are the all fields that where you can apply the recursion. So yeah, you can solve an arrays problem or linked list problem, binary search tree problems, graph problems, dynamic programming, a lot of problems that you can solve using recursion. That is a very important concept that everyone must know. Initially, it's a little difficult to understand, but once you solve the problems, then you will be very confident and you will understand, it's a very important topic, right? So you should understand it, and yeah, you can solve a lot of problems using this. So yeah, that's it for today's session. I hope this will be a really informative for you. So if you really like it, just you can share your feedback to me on my LinkedIn profile. You can see I have share my LinkedIn profile, so you can ping me there and share your feedback at how it was, and it was informative or important for you or not. So yeah, that's it for today. I hope you all are doing well. So yeah, thank you.